All right, so we're going to start out by looking at section 3.3, and it really covers two main things. One thing we're going to look at is factoring, and there's something called the factor theorem, and the other thing is long division. Long division and factoring are kind of tied together, and I'm going to show you guys how with just a simple example with numbers, and then we'll do it more with things like that, okay, with letters. But I want to just do it with numbers first. So just a reminder about a couple different terms that we use quite a bit. Okay, roots or zeros. Remember, if something is a root or a zero of an equation, it's a number that you can plug in and you get 0 as the answer. Here's a very simple equation. What number could you plug in for x that would give you 0? Yep, 3. So you would say that 3 is the root of that equation. You could also say 3 is the 0 of that equation. Any questions on that idea? So that root was easy to find because it was a pretty simple equation, right? It was just a single letter, a number, and then it was equal to another number. Some equations, it's a little bit harder to find the roots. Yeah?
Sorry, roots always equal 0, right? It's not just like...
It's a number that you plug in to get 0.
Okay, yes. But it's not just like x, like solve for x. That's a different concept.
When you solve for x here, that is finding the root. If you're solving an equation that's equal to 0, you're finding a root. So solving and finding roots are kind of the same thing. Now, if you had something like, let's say, x squared plus, let me make up something that works, 4x equals 0. If the direction said solve, you're finding the value of x that you could plug in and get 0. A little bit harder now because it's a quadratic. But does anybody remember something we normally can try to do with quadratics involving parentheses to make it easier to find the zeros? Yep. You try to factor it. And if you can factor it, you're basically going to end up with two things that look something like that. Two simpler problems. So in this case, x plus 3 and x plus 1. That's how that would factor. Now, it's very easy to find the roots. Negative 3 would be the first root. Negative 1 would be the second root. Right? So factoring made it a lot easier to find them. Well, what if you can't figure out one of those factors? That's what we're going to talk about. Okay, what can you do? So if you can't find one of the factors, you can use long division to help you. And I'm going to do an example with numbers first, and then we'll do the exact same thing, but we'll do it with letters. So let's say I told you those two pieces of information. Okay. I want you to factor the number 12. I'll tell you one of the factors, 3. Okay, I'm going to tell you that 3 is a factor of 12, and I want you to find the other one. How would you get the other factor of 12 if I tell you 3 is 1? Yeah?
We should divide 12 by 3.
Right. You divide the number you're trying to factor by the thing that you already know is a factor. So in this case, if I tell you 3 is a factor of 12, that means 3 times something is going to give you 12. How do you find something? Well, divide each side by 3, and you get 4. So that tells you that 4 is the other factor. You could do exactly the same thing with this problem. If I said to you, I want you to factor x squared plus 4x plus 3, and you didn't know how to do it, and I gave you a hint, and I said, okay, x plus 3 is one of the factors you want to use. How could you find the other one? You could do the same thing. You could take x squared plus 4x plus 3, the thing you're trying to factor. In our other case, it was a 12. And divide it by what you know is a factor. In this case, I could tell you x plus 3. If you know how to do this out, you will get x plus 1 as the answer. So you can get the other factor. Same way we divided 12 by 3 to get 4. So if you don't remember how to do that out, that's okay. That's what I'm going to show you. But any question on the idea of how you can take a number, divide by one number you know is a factor, and it gives you the other. Yeah?
The long division, there was like 2 different ways that you could do it, right? There's like a complex way. Is that the same thing?
Yes, there are 2 ways to do it. Tomorrow we're going to learn a different way.
Okay.
Yep. But there are 2 ways to do this. The long division way I'm going to show you today takes a little bit longer, but it works on any problem. The shortcut I'm going to show you tomorrow is faster, but it only works some of the time. So, if you have the problem that it works for, then we should always try to do it the shorter way. Just the shorter way doesn't always work. Now, 3 is a factor of 12. So when you divide 3 into 12, what do you get for a remainder? 0. And that's very important. Anytime something is a factor of something else, when you divide it, you will get a remainder of 0. If you don't get a remainder of 0, then what you just tried to divide by is not a factor. Try to divide 12 by 5. You get a remainder, because 5 is not a factor of 12. Okay, so getting a remainder of 0 is very important. So ultimately, if we can come up with a quick way to figure out when you divide 2 things, if the remainder is 0 or not, that's all we really want to know. Because if it's a remainder of 0, then we know it must be a factor. So this is ultimately what we want to be able to find fast, remainders. And long division is one way to find a remainder. It's not always the fastest way, depends on the problem. So basically I just said that to you guys. If you divide 2 things and you get a remainder of 0, then you know what you divided by is a factor. And the whole point of trying to factor something is what I just showed you with the first example. It's not so easy to look at that quickly and figure out that the 2 answers are -3 and -1. But if you factor it, it is a lot easier. So that's kind of the whole point. Factoring helps us to find the zeros. Now, that process that I just used with the number 12. 12 is the number I want you to factor. Tell you 3 is a factor. Divide 12 by 3 and you get the other factor. We can do the exact same thing with a polynomial. The division is a little bit longer. It's not as simple as just 12 divided by 3, but there's a set of steps we can follow to get the answer. Couple things before we keep going. When you divide 2 numbers, what do you call the answer that you get? Like when you add 2 numbers, you call it the sum. But when you divide 2 numbers, Becca?
The quotient.
It's the quotient. Okay, so we're going to use that word a lot. Quotient and remainder. Okay. So the quotient is what you get when you divide 2 numbers. So what I think I'm going to do is I'm going to put up the steps for doing a division problem. And we'll do the steps on an actual problem at the same time. There's 5 steps. So if you want to put all the steps together, I would leave like 5 or 6 lines to write the steps. And then below it, you could put this example or off to the side, however you want to do it. So the problem we're going to do is x minus 3, and we're going to divide that into x cubed minus 8x plus 3. So quotient, remainder, those are a couple terms that are going to come up. A couple other terms. This is called the divisor, okay, the number that's on the outside. And the number that's on the inside is called the dividend. Dividend divisor. Let's put that up here. If you were to write this as a fraction with one over the other, this dividend would be called your numerator. That's what we normally call it. And the divisor is what you're dividing by. We call that the denominator. So just different words. Okay, so the first step is you look at the dividend and you see if you're missing any terms. Okay, by missing, I mean, is there an exponent that's not there? Look at the highest one, and you need to have every exponent from the highest to the lowest. If you're missing one, we need to fill in a 0 for that particular one we're missing. The reason we need a 0 is because we're going to have to line things up in like terms. So if you look at your dividend, does anyone see what exponent we're missing? Yeah?
It jumps from x cubed to just x, so you need an x squared.
Right.
It's a 0 there.
We need an x squared in there. There are no x squareds, so we're going to just make it 0. So x cubed. Fill in a 0 for the one that's squared. And everything else is fine. So that's our first step. Doesn't even involve any arithmetic, it's just setting it up correctly. Second step. You're going to take the first term of the divisor. In this case, remember the divisor is on the outside, and the first term is an x. And you're going to divide that into the first term of the dividend. The dividend is the thing on the inside, and that is the first term in the dividend. So we're going to divide x into x cubed. So I'll make that a little bit bigger so we can do that stuff. So divide the first term of the divisor into the first term of the dividend. So if you want to think off to the side, what you're really doing is this. X cubed divided by x. Can anybody tell me, what does that come out to? What's x cubed divided by x? X to the second. If you get stuck on it, you can always write it out the long way. X cubed means x times x times x. And in the bottom you have an x. And you can cancel out anything that's in common with the top and the bottom. So as Manny said, it leaves you with x to the second. And we're going to put that up top. Doesn't matter where you put it up top. Put it anywhere you want. Just put it up above somewhere. Right. And that's the second step. So we divide. If you remember from elementary school, a lot of times they use DMS as the acronym. What you do here, you divide, multiply, subtract, and then bring down. We're going to do those exact same steps. This was the divide step. Now step 3 is the multiply step. So we're going to take our answer from step 2. Take our answer from step 2. And we're going to multiply it by each term in the divisor. So think of step 3 as like a distributive problem. That's what step 3 is. And it's important when we do step 3, we have to line things up in columns. And when I say line things up under the appropriate term, I mean line up like terms. Make sure the x squareds are all in a column. Make sure the x cubes are in a column, and so on. So multiply the answer from step 2 by each term in the divisor and make sure we put things in like columns. All right, so let's see how that works. There's our answer from step 2. You're going to multiply that back out to each term in the divisor and just put the answers in the correct columns. So let's start with x squared times x. That's x cubed. You should always get back the same thing you had right here. Always. What about x squared times negative 3? Yeah.
It would be negative 3x squared.
Yep. And that's it. That's the multiply step. Any questions? What we just did right there? Okay, so we divided, multiplied. What's normally the next step in long division? Yeah.
So are you subtracting?
Now we're going to subtract. So step 4 is do the subtraction. So subtract the columns that you just made. Okay, so subtract. And that's basically the last step. Step 5 is repeat. You keep going until you're done. But these are the 4 steps. Well, actually 3 steps. Step 1 is just a one-time thing. But steps 2, 3, and 4 are the steps you keep repeating.
Could I just get the details of algorithm?
It's going to be online. So if you want to be able to see it there, you can just take a picture of that.
Okay.
Or it's actually online right now if you want. You can take a screenshot of that. Oops, sorry. Okay, so step 4, subtract the columns from step 3. So what I do is I go like this. Put a minus sign, put parentheses, and draw your line. And subtract all the columns that we have. There's 2 in this case. Sam, if I subtract the first column, what's x cubed minus x cubed? 0. Okay, that you should always have. Okay, you should always get 0 for the first one. How about the second one? 0x squared minus 3x squared. Yeah.
Positive 3x squared.
That's positive 3x squared. Okay, and that's step 4. That's the subtract step. Okay, so we did the divide, we did the multiply, we did the subtract. The last step is bring down. So step 5, bring down the next term and repeat. So bring down the next term and repeat. And we're going to do another problem like this, so that way we can kind of go through the whole problem without stopping each time to write down steps. So we'll do another one after this one. So let's bring down the next term. The next term is a negative 8x. So the question is, how do you know when you're done? How do you know when to stop? Well, one of 2 things is going to happen. You're either going to end up with a 0 right here, which means the remainder is 0, and then you're done. Or, look at the exponent here and compare it to the exponent there. When that number is smaller than that number, you're done. Okay? It started out with a 3, and that was a 1. Now it's 2, and that's a 1. If we do division again, this number is going to go down 1 more. Okay, so you know you're done when you either get a remainder of 0 or the exponent on the remainder is smaller than the exponent on the divisor, the degree. So keep going in this problem until that exponent on the inside is smaller than a 1. And that's all the steps. And again, that'll be online. It is already online if you want to look at it from last year. But it'll be online today again as well. So now the repeat goes back to step 2. These are the steps that keep repeating. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So those are the steps that keep repeating. All right, so now you're going to divide the first term here into the first term here. So it's 3x squared. That's the first term of the dividend, divided by x. And what do I get if I divide 3x squared by x? 3x. So there's the divide. Now, distribute it back out. Alexis, what's 3x times x?
3x.
Yep, should always be the same as the one above it because those are always going to cancel. And 3x times negative 3. How about Aiden? What's 3x times negative 3?
Negative 9x.
Good. Negative 9x. And Alex, what do I do with those columns now? What's step 3? You write it down? Oh yeah, I would write it down. So if you don't know it, right? Can you help us out?
Step 3.
Yeah. I think it's either what's it, step 3 or 4. It's one of those two. I can't remember.
Like the next step after doing that, it would be.
Yeah, the next step after you multiply.
Oh, that would be step 4.
Step 4, yeah. What is it?
So you subtract columns from 3.
Yeah, subtract the columns from step 3.
Yeah.
Okay? So you want to subtract those columns. Same thing we just did up above. These are always going to cancel. 3x squared minus 3x squared is gone. And Jazara, what's negative 8x minus negative 9x? 1 what? Yeah, just 1x, because that's minus a minus becomes a positive. All right. Lucas, what's the exponent on this x now? It's a 1. What was the exponent on what we started with?
1.
A 1. Now they're the same. We got to go one more time. We have to keep going until this exponent is smaller than that one. But notice it went down each time. It was a 3, it was a 2, now it's a 1. So this is the last time. Okay, bring down our next term. All right, now divide the first term on the outside into the first term on the inside. So this time you're doing x divided by x. And x divided by x is going to give me how much? 1. As far as our division problem, we are done the quotient. This right here is the quotient. We need to keep going if we want to get the remainder. And a lot of times the remainder, that's the most important thing, because we want to know whether or not the remainder is 0. So 1 times x gives me x. 1 times negative 3 gives me negative 3. And subtract. Why? When I subtract there, what's x minus x going to give me?
0.
Yep. So that cancels out. And Matt, what about 3 minus minus 3?
3 minus minus
6. Good. That's my remainder. All right, so a couple ways we can write our answer. You can write it quotient and remainder. So the quotient is x squared plus 3x plus 1, and the remainder is 6. Now, since I didn't get a remainder of 0, what does that mean about x minus 3? When I tried to divide it into that, it's not a factor. So if you were trying to factor x cubed minus 8x plus 3, that is not what you would use. What would you use? Well, you don't just keep guessing. There's a way to figure out what you should use, but it's not x minus 3. Okay, so you can write your answer that way, or you can also write your answer. This is just an example with numbers, so this is separate. But I think if I show it with numbers first, it'll make more sense with letters. When you divide 17 by 5, what's the quotient? Yep, 3. And what's the remainder? 2. So one way you can write your answer to a division problem, when you get a quotient of 3 and a remainder of 2, is you can write the quotient plus the remainder over the original divisor. That's one way you can always write your answer to a division problem with numbers. The quotient was 3, the remainder was 2, and the divisor was 5. So when you divide 17 by 5, the answer is 3 plus 2/5. And in math, we normally would write that as a mixed number and say 3 and 2/5. The important thing is this. You can do the exact same thing we did with numbers with letters. So in our case, our quotient, yep.
Sorry, can I just ask, the remainder is 6. Can you scroll up a bit? Okay, if that's because you distributed out again to get that x minus 3.
Yep, and that comes from 3 plus 3. Yep. So let's follow the same pattern we did with numbers, but now just do it with this. Quotient plus my remainder over my original divisor, which was x minus 3. There's another way that you can write the answer to this one. Both are correct. Any question on that? Yeah.
What way would you prefer, like, if you, I know we don't do rate tests, but if we were to do a rate test, is there a way, like, is there preference at all?
What I'd probably do, the easier one would be on Edge Elastic if I put a box that said quotient and then a blank box and then the word remainder in a blank box, and you just had to type in those two things.
Okay.
That would be the easiest setup, where you could get partial credit because you could get the quotient right and get the remainder wrong, but you'd still get half credit because you got something right. That's probably how you'd see it on there. If it was a multiple choice question, then I would say it could be either one. You just have to pick. You wouldn't have both of these listed as multiple choice answers because they're both correct. But if it was multiple choice, I might do a quotient and remainder style, or I might do it like this second style. All right, let's try this one. So at first, when I look at this one, it looks like it's going to be even longer because it has a higher exponent. This is going to be shorter than the last one. You'll see why. Something's going to happen. Now, the first thing, they filled in a couple zeros. That's normally not going to be done for you. But I filled in 0 for the x and the x squared terms. All right, so Elva, what's my first term on the outside?
1x squared.
we have an x squared there, but what is it again?
Oh, well, 2x.
2x squared. So you're going to divide this into what on the inside?
The 2x.
You're going to divide that into 2x to the 4th. So either in your head or off to the side, you're doing this. What's 2x to the 4th divided by 2x squared? Yep.
X squared.
X squared. Doesn't matter where you put that. You do not have to line that up with anything. Just put it above somewhere. So x squared. Chris, what do I do with this x squared?
Sorry.
So what's step 3? So I'll help them out. Step 3.
You're gonna distribute it back out to the denominator. Divide.
Step 3 is to multiply the answer back out. Take this, and multiply it back out to everything. Jalen, what's x squared times 2x squared?
2x log to the 4th.
Yep, 2x to the 4th. And Jess, what's x squared times x?
X to x cubed.
X cubed. And Casey, what's x squared times 1? Just x squared. And Kelly, what do I do with those 3 columns now? I'm going to take each one of them and yep, we're going to subtract them. Okay, first one should always cancel. 2x to the 4th minus 2x to the 4th. Negative 1x cubed minus another 1x cubed is minus 2x cubed. And this is why we put in the 0. 0x squared minus 1x squared minus 1x squared. Okay, so we did the subtraction. And now bring down the next term. Even if it's a 0, that's fine. Just bring it down. Okay, who can tell me what the next division step is that I do? I usually write it off to the side so I can see it. If you can do it in your head, that's fine too.
You take the first term of the divisor and you cut it to negative 2x squared.
So we're going to have negative 2x to the 3. Take the first term in the divisor. And we need to know what that would come out to. What's negative 2x cubed divided by 2x squared?
Negative x.
Yep, negative x. Now, this is where I said something is going to happen that's going to make this problem basically be done right now. Multiply this back up. Negative x times 2x squared is negative 2x cubed. What's negative x times positive x? Negative what?
Negative x squared.
Yep, negative x squared. And negative x times positive 1 is just negative x. Now, watch what happens when we subtract. What's negative 2x cubed minus negative 2x cubed? Yep. 0. What's negative x squared minus negative x squared? Yep. 0. In the last step, 0 minus negative x. That's positive x. And bring down the 2. What's the exponent on my x minus 2? 1. What was the exponent on the outside? 2. This exponent is now smaller than that exponent, and we're done. Just write your answer. So quotient, x squared minus x. Remainder, x minus 2. You'll notice the pattern with most of these problems. The work goes down and to the right. So when you do a long division problem, you don't want to start it on the right edge of the page. You want to start towards the left, because that's the way the work is going to go, to the right. Okay. Any question on that? Yes?
Would the written out version be x to the second minus x plus x plus x minus 2 over 2x to the second plus x plus 1?
Yes. Yep. Yep. You could always write it as quotient plus remainder over divisor. That is the other way to write the answer. There's your quotient. There's your remainder. There's your divisor. Okay. So, let's see. What I want to show you guys is, I talked about the remainder earlier. And we said that if something has a remainder of 0, then what does that mean? If you divide two things and get a remainder of 0, it means that what you divided by is a factor. And that's, a lot of times, all we want to know. So, is there a quicker way that we can get a remainder, if that's all we want to know, and we're not interested in the quotient? The answer is sometimes. In this problem, no. In the first problem we did, yes. There was a faster way to figure out this 6. Not to get the quotient, but to get the 6, there was. And that's called the remainder theorem. The remainder theorem only works if you divide by something that can be written in the form x minus a number. If you look back at the first problem we did, it can be written as x minus something. So in the top, you're going to have a polynomial. I don't know what it will be. In the first one we did, it was x cubed minus 8x plus 3. That was our numerator. That was our dividend. And we divided by something that could be written x minus a number. Whatever number is in that box, if you take the number in that box and fill it into the top in place of the x, it will give you the remainder. I'm calling this value c. That's what I called it in mine. So not the minus, just what's in the box. So take what's in the box, plug it into the top, and you will automatically get the remainder. We're going to go back and try it on the first problem right now and see if we get 6. Yeah?
X minus c, what does that represent within the problem?
That represents what you're dividing by.
Okay.
So in this case, we divided by x minus 3. So this is a problem that theorem would apply to. In this one, we divided by 2x squared plus x plus 1. That is not x minus c. So the only way to get the remainder on this problem is to do the whole thing out. There is no shortcut. But this one is. So we had x cubed minus 8x plus 3. And we divided by x minus 3.
And the top is your x, and the bottom is your x minus c.
Sorry, what?
Could you go back to the equation that we showed? Yeah. So f of x would be
The x cubed thing.
yeah, yes. And
Yeah.
then x minus c would be x minus 3.
In this case, the c value is 3. Yep. So we're going to take the number that comes after the minus sign, and we're going to fill it in for x and see what we get. Right. Let's try it. Take the number that's after the minus sign, which is 3, and fill it in for x. So 3 cubed minus 8 times 3 plus 3. What's 3 cubed? And that's not 3 times 3. That's 3 squared. Yep.
81.
That's 3 to the 4th.
Yeah, it's 3 to the 4th. It's 27 then, right?
Yep, so 27. 8 times 3 is how much?
24.
24. What's 27 minus 24? And 3 plus 3? 6. And look what we got for a remainder. 6. So that, doing this calculation would instantly tell me that x minus 3 is not a factor of x cubed minus 8x plus 3. What's the quotient? I don't know. This formula doesn't do anything to find the quotient. It just is a quick way to find the remainder. Yep.
So the remainder theorem only really works if your divisor is x minus or plus something, or is it just x minus something?
It only works when you divide by something like one of these two things.
Okay.
So we're going to take and find the remainder when we divide f of x by x minus 3. And then we're going to divide f of x by x plus 1. Now, you might look at the x plus 1 and say, wait a minute, you said it has to be x minus a number. Well, that could be x minus a number. If you think about it, it is. We just have to fix it. But these are the only two things you can really divide by and use this shortcut. Yep.
So, like what we had, not this example, but the example before that, 2x to the second plus x plus 1.
Yeah.
Can't use that, right?
No.
On B2.
Can't do it. Yeah. This doesn't, that theorem I just showed you doesn't do anything on this problem at all. It won't work at all. Yep.
Is there a way you can use the remainder to find the quotient? Or would that be like impossible?
Not really, unless you knew more information.
Yeah.
Because like if I just told you I'm thinking of a problem in my head and the remainder is 3, you can't really work backwards and figure out what the quotient was without some more information.
Yeah.
Yeah. But with the right information, yes, you probably could. All right. So here's going to be my numerator. And I want to divide by x minus 3. So set it up like this. Let's put the remainder right here. When I divide f of x by x minus 3, what number am I going to plug in to f of x to get the remainder? Yep, 3. So you're going to plug 3, because that's the number after the minus sign, in for x. So it's 3 cubed. Let's do some of it as we go. What's 3 cubed?
27.
So 27. What's 3 to the second power?
9.
Times 2. So 18 plus 3 minus 5. Our space. Okay, 27 minus 18 gives me how much? 9 plus 3 minus 5. What's 9 plus 3?
12.
And what's 12 minus 5? 7. So now I can very quickly answer the question. Is x minus 3 a factor of x cubed minus 2x? No. So x minus 3 was not a factor. Now let's try dividing it by something else. Let's try x plus 1. Well, first of all, you have to think of it this way. It has to be x minus something. How can you rewrite x plus 1? So it's x minus something, yeah?
X minus negative 1.
There you go. Now it's the number in that box that you plug back into the original numerator. So the number after the minus sign is a negative 1. Any question why we're going to fill negative 1 in for x? Okay. So negative 1 cubed is negative 1. What's negative 1 squared? 1 times negative 2 is negative 2. Minus 1 minus 5. Negative 1 minus 2 is negative 3. Minus 1 more?
-4,
Minus 5 more?
-9.
-9. So the remainder, when you divide by x plus 1, is -9. Ultimately, it means it is not a factor. Yes?
Just to kind of reiterate, what you're doing there is substituting in that 3 value for root x.
Yep.
Like, and are you solving it out so it's like x minus 3 equals 0, and then you have to get the x with 3 over, and it becomes a positive 3, or is it just taking that value out of the problem and putting it?
Just plugging it in. So basically, that's what we did.
So that
F of 3.
that x minus 3 then isn't negative 3, it's just 3.
It's just what comes after the minus. Yeah. Okay. Any question on? Yeah.
So for the x plus 1, it goes with any number, right? Not just 1. So like it goes like x plus 3, like in the box would be -3.
Yeah. Yep. Yep. Okay. I think I'm gonna skip that. Okay. So let's use the remainder theorem to show that x plus 2 is a factor of that. Now, one way to show it's a factor is to do a long division. I don't want to do the long division. I just want to use the remainder theorem. So to use the remainder theorem to show that something is a factor, you need to show that you get a remainder of what? 0. You have to show that the remainder comes out to 0. And I'm telling you this time it will. Well, let's see. So this x cubed plus 5x squared, all that stuff, that's like my f of x. The x plus 2 is what I'm dividing by. So think of it like this. We need to take the number that comes after the minus sign and fill it into the top. But I don't have a minus sign in the bottom. I have a plus sign. So how am I going to think of x plus 2 so that it's x minus something? What am I going to do?
X minus -2.
X minus -2. And it's this that you're going to plug into the top. It's always the number after the minus. Any question why we're plugging -2 into the top? Okay, so let's do it. So my remainder, fill in -2. -2 cubed plus 5 times -2 plus 5 times -2 minus 2. What's -2 cubed? Yep. -8. What's -2 squared? 4 times 5? 20. What's 5 times -2? -10 minus 2. Now just do it out. -8 plus 20 is 12. What's 12 minus 10? 2. And 2 minus 2? 0. And this 0 is my remainder. So that means because I got a remainder of 0, that means x plus 2 is a factor. So now, if I wanted to try and factor x cubed plus 5x squared plus 5x minus 2, one of the factors would be x plus 2. How do you get the other one? So now it's like I'm telling you this is one of the factors. It's like the very first thing I did with the number 12. I told you 3 was a factor. How did you get the other one? Yep.
You have to divide that by x plus 2.
Exactly. And what do you call, when you divide it, what do you call the answer?
Quotient.
The quotient. That would be the other factor, if you wanted to factor it. You know that x plus 2 is a factor, so divide it and get the quotient, and that's the other factor. Yeah.
How did you get -2 to do that? Or divide into that?
-2, because it's x minus -2.
I know, but you go from x plus 2 and then equals x minus 2, and I think I missed how you got there.
Well, it's still plus, it's just x minus -2. Because it has to be written x minus to use this theorem.
Oh, okay. So you just change around the...
Yeah, you got to change the denominator so it's always x minus a number. If it's already x minus, then just go with that. If it's x plus, you need to fix it. But that's the only case that this theorem works. So this theorem is pretty limited. It only works a very small amount of the time. But it works perfect for this problem. I'm not worried about actually finding the quotient right now, because tomorrow we're going to learn a faster way to do this kind of division problem, where we don't need long division. Okay. So I keep mentioning the terms zeros and roots, so I just kind of want to recap what that all means. So remember, if you've got a number, I'm just going to make up x minus 5 equals 0. In that case, the root would be 5. So if I was using that as my example, I could say that 5 is a solution to that equation. I could also say that 5 is what we call the 0 of that equation. I could also say that 5 is the root of that equation. Now, let's get that. I want to go back to the very first thing I said, where I wrote a quadratic equation down, and then I factored it. I'm going to go back to that, and then I'm going to come right back to this to tell you the fourth and the fifth thing. Let's go back to what we started with. Where was it? Right here. What's in that red box? What were the two roots for that equation that's in the red box? Yeah? -3 and -1. So now, let's go here. The roots were -3 and -1. Can somebody, it was just on the board, but can somebody work backwards from that and tell me, what could I put here and what could I put here so that I could plug -3 into this one and plug -1 into this one, and it would come out to 0. Yeah?
You want both of them?
Yeah.
The first one would be x plus 3, and then the second one would be x plus 1.
And can you tell me, how can you think of x plus 3? Because in this lesson, we tend to think of things as x minus. So what would this be?
It technically would be x minus -3.
Mm-hmm. And this one?
X minus -1.
Right. And this is basically the whole cube. If you know what the roots are to a problem, and you want to work backwards and get the factors, take each root and plug them into something that looks like this. X minus, and then put in the root. And then do the other one. X minus, and fill it in. So if you knew a number was a root, then x minus that number is a factor. That's important. So if you have a number that's a root, then x minus that number is a factor. And the reason why that's important is because in a minute, I'm going to give you a problem, and I'm going to tell you the three roots, just like I did right here. I'm going to tell you the roots, and I'm going to want you to work backwards and give me the two factors, or three factors. However many roots you have is how many factors you have. They're the same. All right, so let's go back to that list of things. So if you know that a number is a root, then x minus that number is a factor. And the last one has to do with thinking about it visually. Okay, these are all things that mean the same thing. It's just different ways of saying the same exact thing. What number would you plug in for x to get 0 for y? 5. So if you plug in 5 for x, everybody agrees you get 0 for y? What do you call this point? 5 is the root, because it gave you 0. But if you graph this point, 5, 0, that's something special about this line. It's where the line does what? Yeah?
Crosses the x-intercept.
It's where, can you say it again?
Crosses the x-intercept.
It's where it crosses the x-axis.
X-axis, yeah.
It is the x-intercept.
Yeah.
Yes. So once you know the root to an equation, graphically, that means it's where it crosses the x-axis. What do we call the point where it crosses? We call that the x-intercept. So zeros, roots, factors, x-intercepts, all different ways of saying the exact same thing. Let's try a problem now where they give us the roots and we have to work backwards to figure out the factors. Yes?
See, that variable, just, is that representing the fact, like, what is the variable C represent?
C represents the root.
Okay, so then we go to zeros.
The root, or you could also say it represents the zeros. Let's try this one. Let's just make that 2. So degree 2 means it's a parabola, means it's a quadratic. So I basically want you to find a parabola that crosses, find a parabola that crosses the x-axis at -2 and +3. So these are my roots. These are my zeros. When you write a parabola, how many sets of parentheses does it have when you factor it? 2. It always has as many as the degree. If it was a degree 3, we would need 3 sets. Degree 2 is going to have 2 sets. If -2 is one of my roots, what would be the factor that it came from? Yeah?
X plus 2.
Yes. I could plug -2 in for x and get 0. That's what it means to be a 0. If 3 is another 0, what would have to be right here so I can plug 3 into it and I get 0? Yep.
X minus 3.
Yep. And now to find the polynomial, just multiply this out. So we get x squared minus 3x plus 2x, and 2 times negative 3 is negative 6. I'm not going to graph it, but if you did graph that on your graphing calculator, x squared minus x minus 6, it would cross the x-axis at negative 2 and positive 3. So that's working backwards from roots to find your equation. We're going to finish up the last one. I'm going to give you something like this again, and we're going to practice factoring. So we're going to do this problem the other way. That'll be the last one. Yep.
Wait, you said that it would cross the x-axis at negative 2 and positive 2?
Negative 2 and positive 3.
Negative 2 and positive 3. Okay.
Yep. Any questions on how we got x squared minus x minus 6?
Did you get the minus x? Sorry.
The minus x, negative 3x plus 2x. Negative 3 plus 2 is negative 1. Negative 1x. Right, and last one. So this time, you have to find the zeros. I'm giving you the equation. We're going to work backwards to find the zeros. And they give us a hint. They want us to factor it. And they want us to try factoring by grouping. Factor by grouping usually applies when you have 4 different terms. To use factor by grouping, look at the first 2 and factor out anything they have in common. Then look at the second 2 and factor out anything that those have in common. So look at x cubed plus 2x squared. Does anybody see something that those both have in common? Yes?
X squared.
X squared. If you factor x squared out of both of them, what would be left inside my parentheses? Yep.
X plus 2.
X plus 2. Now, we haven't, that's the first part. The whole goal with factor by grouping is when we factor out what the last 2 have in common, we need to get the same thing in parentheses again. That's what's supposed to happen. If it doesn't happen, then we can't use factor by grouping. But they said to use factor by grouping, so here we go. Look at negative 4x and negative 8. Does anybody see what we can factor out of both of those? And I'll give you a hint. We're going to start by factoring a negative out. And now I need a number to go with it. Yeah?
Negative 4.
We're going to factor out a negative 4. If you factor a negative 4 out of negative 4x, what's left? So negative 4 times x is negative 4x, and negative 4 times what is negative 8, plus 2. So now we ended up with the same thing in this term and that term. There's 2 terms here now. Terms are separated by this minus sign. Both of those terms have an x plus 2 in them. So now take the x plus 2 out of both of them. If we take x plus 2 out of the first one, what do you have left? Yeah?
X2 minus 4.
Yep. So x squared. And if you take x plus 2 out of the second one, you're left with minus 4. This term is as simple as it can get. X plus 2. But x squared minus 4 factors. Does anybody see how x squared minus 4 factors? It's called a difference of squares. It's going to factor into 2 things that are the same, except for the sign. So same letter, same number, one's a plus, one's a minus. Yeah?
X minus 2 and x plus 2.
Yep, x minus 2, x plus 2. Now that we've fully factored it, we just look at each one of them and tell me the number you would fill in to make each one 0. Start with the first. What would you plug in for x to make this first factor 0? Yep. Negative 2. What would you plug in for x to make the second one 0? Yep. 2. And what would you plug in for x to make the third one 0? Negative 2. Negative 2 is what we call a repeated answer. You don't need to write that it's repeated. You've already listed it once. That's So those are the answers. A lot of times you get 3 different numbers. This time we only got 2.
So you might have just answered it. So I feel like we're supposed to get 3 answers, like because it's in the original equation it's cubed. So
Yeah.
shouldn't we have 3 answers?
And technically you do. They're just not unique. So it's like having a Jess, and a Frank in the room. Technically it's 3 people, but it's only 2 different names because one of the names is repeated. But it's still 3 people, obviously.
So that x equals negative 2, comma 2, that was the zeros. We found the zeros.
Yep, those are the zeros. Specifically, if you wanted to list all the answers out, it's -2, -2, and 2. Those are the 3 answers. It's just -2 is repeated.
So why do you write it just as values rather than coordinates like on graph?
Because the directions specifically said to find the zeros.
Yeah,
A zero is just a number. If it said find the x-intercepts, then you would be writing this. That's how you would write x-intercepts. Intercepts are always written as coordinates. Roots or zeros are written as single numbers. So a little bit of a difference between the 2. Any other questions on it? So that's 3.3. Alright, so that's homework for tonight, 171. On the 13 to 19, that's just odds. And just odds. So we'll go over that tomorrow, and then after we do the homework, I'm going to show you a quicker way to do division, but it only works some of the time. Okay, when it does work, it's good to use it because it's faster, and that's called synthetic division. If you remember that.